Hello, my name is Jack Bed and welcome to my channel, or welcome back to my channel. Today we're playing Satisfactory, and specifically we're going into the subject of advanced logistics. Now, you might ask, what is advanced logistics? Is it the trains? Is it the drones? Is it making the trains and the drones speak? No. What we're talking about with advanced logistics is something as simple as, instead of focusing on developing better ways of moving more resources, you are going to flip that on its head, and now you're trying to make resource effective way to transport those resources, because that reduces building time, resource use both for your computer and in game, and ultimately you will be able to build without spending like 30 hours without any progress. And this is what like people miss, because this is a complex thing. They kind of skip it, and that's because it's uncomfortable. And I want to help today and see if I can get you on the road to building those heavy modular frames a lot easier, or faster at least. They are more complex, but faster. Let's go into this. So let me first demonstrate the standard logistics. This is the method that you recognize. This is the one that everyone uses, and the one that is pretty much standardized from beginning of the game to the end game. So that basically is that you keep your resources separate like this, and they go into their own separate but parallel production lines. So you have your iron, it goes over here, and it goes in, it becomes iron ingots, and then those iron ingots can go to a different production place and become iron plates, and then it continues on and gets stored or sunk, or used in a different part of the factory, right? And then the same thing goes for the copper, and the same thing goes for the limestone. But as you can see, if you look from top down, what I want you to focus on here is the amount of belts. Remember, each belt placed, barring blueprints, is something that you have had to place down manually and align and make sure that they go where they're supposed to go. That is the biggest time sink for Satisfactory. That is what takes up the vast majority of your time. So, advanced logistics has the purpose of reducing that to the bare minimum while still keeping your factory equally as efficient. That is what we're doing today. So, let's take a look at what the advanced logistics does differently. All right, and if this is something that fascinates you and you like this video, make sure to show that with a thumbs up, subscribe to the video, and if it's really cool, make sure to share it with your friends. Now, let's check out advanced logistics. So we have the same setup, right? Right? No, we don't. This entire setup has been, like, of course, this is more spread out for visual clarity. And this is still spread out for visual clarity. So, but it makes the same stuff. Literally the same production cycle. And the only thing that you need to keep an eye on is, hey, do they actually run efficiently? So how are we doing this? Well, first of all, we're merging up everything onto one belt. If we go out of photo mode, if I can do that there, and we can go down here and we can take a look, this uses 30, like all of them use 30, and they go on a Mark 1 belt over to a Mark 2 belt. And there they collect, and they go down, and here we got smart splitters, and they go to each direction. This one takes care of our, what's it called, limestone, and turns it into concrete, and then goes down, and the copper goes to the left, and is dealt with and turned into ingots. Now, something happens here, because we had a full belt here. Because we're sending in 30 concrete and getting 10, or limestone and getting 10 concrete back, we're now freeing up 20 space on the belt to continue with, right? But we haven't added more yet. Au contraire. No, we are sending the iron down now. The iron has 2 smelters here, and we're also sending in the copper. Now the copper, however, causes a bit of a problem, because that one goes and doubles. How dares it? Now, the only thing that we need to do then is make sure that the next part of our production cycle, if we go down here, reduces the amount enough that we can fit them on the belt again. And we do that by turning iron ingot into iron plates, reducing the iron ingots by, or iron pressure on the belt by a third. And that means that when we get to the end here, what we have rolling, it should say 110. There should be an efficient, nice round 110. And the reason why it's not is because these haven't fully adjusted to being on yet. But essentially, what we have here is the same amount of production happening, right? But look at the number of belts, right? Compared to this. This took me about 15 minutes to build. This took me about 5 minutes to build. And that is because we are using the most overlooked block in the game, the smart splitter. People use it for sushi belts. Like, people will call this a sushi belt. I know you guys. You can say it in the comments. You can hate on me. And you have sushi belts. But instead of having an input sushi belt and an output sushi belt, like, why? If they can fit on one belt, if you can plan the logistics so you just have to build one belt, why don't just build one belt, right? So that's essentially the plan here. You want to reduce the number of belts to the absolute bare minimum. Sadly, we don't have the same mechanical luxury with pipes, with liquids that we do with the solids. So we're kind of screwed when it comes to trying to do something similar with liquids. But we will also be looking at what's an example of this, but with the trains, right? So what do we have over here? So I gave myself a challenge. You need to run 3 trains on the same route on a single railway, but with no signals. And I did. So if we take a look behind me, you can see that we have iron mine number 1, copper mine number 1, and then we have the limestone mine number 1. And then we have the dumps over here. The iron dump 1, copper. Why do I have hiccups? Stop hicking. I don't have time for this. I have guests coming. Okay, so we have the copper dump number 1 and limestone dump number 1. Here's something that we need to do. We need to run these in a sequence so that all trains are switching places with each other. And we also need to make sure that the timings means that they don't ever crash. Because they won't go like, oh, there's another train there. No, it will just drive. And there will be a crash, and it will be horrific, and the puppies will cry, and the kittens will die. Now, how does this work? So I've set up here 15 seconds is the amount of time that the iron, we need to focus on the stations, not the trains, when it comes to the timings. So the timings for the iron section is 15 seconds. That's the waiting time, mandatory waiting time. 10 seconds for the copper mine, and 5 seconds for the limestone mine. So if I've done this correctly, or if the trains are just messing with me, what will happen now is I should be able to start. Let's go here and turn on self-driving for the iron train, the one underneath me. And then this is gonna be messed up, I think. Yeah, they're not going to the right places. Doesn't matter, it should still work. And then there we go with the last one. So as you can see, iron is going in there now. The limestone train is going over to where the limestone is. And then this one, when it's waited, it's 10 seconds. Or apparently it's going through its loading still. They're very, trains are weird. Hopefully, what will happen now, because that one is heading for the copper, right? This one, like if we look on train 1, where are you going? Copper mine. So this needs to be empty by the time it gets there. And is it? It is. Ta-da! So if we've done this correctly, even if they go in like this simultaneously, they need to wait the same amount of time, right? So they should stay the same amount of distance from each other constantly. Just checking. That one is a little bit faster. This one is a little bit faster. No, slower, sorry. Yeah. Let's go. I think something is off with the timetable here. So let's go in and check. And edit timetable. Yeah, okay, that explains it. That shouldn't be 5 seconds. That should be 10 seconds. That explains it. Okay, so if we don't fix this, there's gonna be a problem. Edit timetable. 10. Save. Copper dump. 10. That is correct. Limestone should be 5. That's correct. Limestone. E5. And this is a challenge that I gave myself to make the logistics more compact. So I basically have less. There, save. There, save changes. Boom. Now this essentially, I ran it yesterday when I was building this. I ran it for I think like 4 hours without any crashes, so I know it works. And we will leave it at that because we have one final thing to show you. And if you want to know more about this kind of stuff, tell me in the comments. Now let's look at the last bit. I promised you to make easy heavy modular frames, didn't I? Heavy modular frames being run from 2 belts. One to the right that only starts off with 300 iron, and the one to the left starts off with 1200 resources total. 300 limestone, 300 copper, 300 coal, and 300 iron. That is what the left one starts with. The right one starts with 300 iron. And now we have literally just done what we did before. So let's go in close and take a look at it. So it looks it looks more hectic than what it is. So break it down into station. This one takes care of 300 of the iron and turns that into ingots. And this takes care of the copper and turns that into ingots. Now we are just sending the limestone and the coal onwards. We don't need those yet. And we are sending the iron in here to this station where it's getting processed and turned into ingots and then back on the belt again. So we're going back to the belt constantly. Now we need to do kind of the same thing as before. We can't have too much of stuff that is being multiplied by its production, as in the wire. A lot of this is overclocked. A lot of this is like just big mess. It looks like a big mess. It is not. So they go in here, they get processed into wire, and then they go over to the other belt because there's plenty of space. We only send 300 iron there. And all of this has been turned into if I remember correctly, that's a 1-to-1 recipe. Yeah, but this one removes a third. So that means that there's even less on the belt. We have plenty of space. Now, here's the fun part. Here's where we introduce our programmable splitter. So I have just set it to overflow in the middle, just like any smart splitter, but I want to make reinforced iron plates here. And I'm using the alternate recipe stitched iron plate. So what I have done here is simply make a programmable splitter that sends the right to the right. It sends the appropriate resources. That is then on the same, like it's on its own, like belt that is set to feed and then send on with overflow. Like the smart splitters are great for this. And then if there's anything left over after we have sent in everything, it goes back out, joins the merging line, the output, and then I'm sending it back, boop, over here, like back here. Because then it keeps cycling in to be used. So I'm basically, I'm literally recycling the same line, right? And then down here, we also want to send, because remember, now we get the reinforced iron plate. It goes in here, boom, before it's even made. Is this a time paradox? And then it makes our modular frames, which is the ultimate thing we want to do on this line. As you can see, after this, I'm merging up this line with the other one, because now we have used all of the wire, we've gotten rid of a bunch of the iron. What little is left, we need to actually make the heavy modular frames, or they are a surplus overflow that we can send down the sink. And then, if we go back up here and look at this, so we make the copper, we make the iron right, and then the copper goes in here, makes the wire, and goes down there. But if we follow this line, now we split off all of our concrete. And here's what we're doing with it. We have set up a quite elaborate slooped production setup that uses 100 limestone per machine, so that I only need 3 machines. Less machine equal better for this. Same thing there. Less stuff equal fast build. That's what we want with this stuff. And then we get that back on the belt. And then we move down, and over here, once again, programmable splitter. Now we're making steel. So we need to send 2 items to the left. And instead of having 2 smart splitters, I have 1 programmable splitter. Once again, reducing the amount of buildables I am using in total. That makes it faster to build. That is what we want. It means that it doesn't take 20 hours to build a heavy modular frame factory. This took me 4 hours. With everything, including setting it up in modular and double checking things and like making sure that the belts are running and troubleshooting, like start to finish. This makes heavy modular frames 4 hours. That's it. That's incredibly fast. Now, let's see here. So the steel is being made, right? Any surplus iron, because we don't need all of the iron, I think. No. We're getting some of the iron from over there as well, remember? And then we make 300 here. And this setup needs 300 total. So there's going to be a little bit left. But they go in here, they make steel. It doesn't look like that's... Why isn't... Okay, coal is going in now. Okay. Like, it's just... It hasn't been running that long, so it's not fully saturated. But yeah, now what we're doing here is we are making steel pipes. Once again, why are these not running? Are they not set up? They are not set up. That explains a lot. Hey guys, I need you to be set up. There we go. And boom, now we're making steel pipes. So now we're making a ton of steel pipes and we're sending them back before we even made them. Once again, time travel is cool when you're using advanced logistics. And then we send them into a programmable splitter where we have set to the right output, we're sending the steel ingots for the pipes, right? Forwards, we're just overflowing everything we don't want. And then programmable splitter moves everything to the left that we need to the left. Everything you own in a box to the left. And we got concrete and steel pipes. That's apparently what you own. And they are making our encased industrial beam. And once again, smart splitters with an overflow that merges with the output line and then goes back onto the main belt. And here goes the... once again, these haven't been producing the way they should because all the steel pipes weren't being made. But now it can go down here, and we have a programmable splitter that sends 4 items to our left and the rest is being overflowed. And we can easily just like take this stuff, right? Like I can go in here and just look, okay, or rather over here, I can go here and look and say like, okay, I know what's being overflown, I know what we have more of than we need, and I can grab from that and send, instead of syncing that, I can send that onto the next factory belt that is making the next part that needs those kinds of resources. So yeah, I like this is super simple in terms of setup. I have also exaggerated this because there's a bunch of very obvious flaws to anyone who's played this game a little bit. And one of them is, if we take a look at the recipe being used here, it conveniently uses very few items compared to some of the other recipes that definitely do not use very few items. 390 per minute. We don't want that like here, right? That would suck. And the reason for that is like I'm showcasing the advanced logistics. Advanced logistics being how to make the logistics itself more efficient, smaller, and less resource demanding and time demanding to build, rather than how to move resources more efficiently. Like how to get them from point A to point B faster or in larger quantities or whatever. Like that's the standard logistics. Advanced logistics is achieving the same results with less. And what you kind of want to do to make this a functional part of a factory or a satisfactory save isn't to suddenly stop building your standard factories like the ones over here and then only build these. I have exaggerated this. I want to be clear, this is an exaggerated setup. Don't build exactly like this. This is a concept, not a practical setup. And the reason for that is there is such a thing as bulk lines. Any factory will have them. You will have a line like this one that is actually a manufacturing line, right? That you have here, and its job is to do exactly what the one we have set up does, right? It has machines on the sides like this, and it takes from those machines and it sends back to the belt when it's done, and it keeps going, and so on and so forth. Okay, that's like whatever. However, if you, for example, are processing like 7,000 iron, and you are trying to fit that onto a production belt, that's not gonna work. So you need to have, like if you do this, and you have your bulk setup over here, all right? So this is how you practically would use it, okay? You know how much, like you look at what the total is, right? So you look at what the reinforced iron plates over here. You know that you want modular frames over here. So now you know how much resources will be on this belt total. You look at your modular plan or whatever it is for that specific part or for the end product, and you go, okay, I know this will need 400 items per minute total in terms of ingots, in terms of screws, in terms of wire cable, in terms of whatever it is you need, right? And then that's the belt you use, right? Mark IV belt. Like you get that? Like you don't go for the biggest belt you can just because. You can, but only if you actually need to. So what you now plan for is the same as what I've done over here. So when these have made all of their iron, right? Then you collect all of that iron and you send it to the appropriate, or to an appropriate splitter, right? So, for example, I put in let's make it simple. here's a smart splitter. So smart splitter goes here, right? And I'm telling it, hey dude, you need to send so many iron over this way, right? And when you're sending that iron, there is going to be an overflow. So what you're going to do, you make it say like, iron go over here. Let's be visually clear here. And we don't want anything to go in the center, but we want this to overflow. This is the worst possible setup I could have done in terms of like visual clarity. I apologize, but we're looking at advanced logistics, so I assume that you have a solid grasp of the game at this point and can kind of understand my ramblings. Now, if this is your first time playing Satisfactory or any kind of logistics game and you're new to it, go and check out my logistics guide, part 1 through 2, 3, and 4. It perfectly explains the standard logistics, not advanced logistics. This is advanced logistics 101. Your classroom is down the hall. Also taught by me. I'll see you over there. Now, this is the overflow. This isn't being used for anything, right? But we will still need it. And we are not going to be needing all of the iron that is being sent down here. So what we will do is take another... we take a merger. And whatever's left after we have produced goes back onto our iron bulk line. That then continues on. Okay? So you use the standard methods, the standard logistics for bulk production and bulk transfer, and then you split off as if it's a manifold that needs to be saturated. So the belt like uses and makes all the stuff you need, and then whatever's left comes back over here and goes down here. Okay? Easy peasy lemon squeezy. And a very, very simple way that you can control this is by changing belt speeds. So, if we know that we are producing 480 here, this is a Mark IV belt, so if we know we have 480, I can very, very easily say, I only need 120 out of this. So I will make a short section of Mark II belt, and then I will grab my Mark IV for the transfer speeds, because I'm not a complete psycho. I know, I just built this and said I am not a complete psycho, but now I have, no matter how fast the belt is at moving things over there, it can only move 120 pieces per minute past this line, right? Because the transfer speed and the throughput rate are two different things. And that is basically Advanced Logistics 101. I am actually thinking of doing a full playthrough where my mission is, in as many places as possible, like exaggerated like this, use advanced logistics and make a kind of mix between a masterclass or in advanced logistics application as well as a let's play. And what do you guys think about that? Tell me down in the comments. If you want to support and help me make more of this chaotic goody, then make sure to head on over to Patreon and support. There's links down in the description. You can support from $1 a month. And now I need to get ready for guests. So have a great one, everyone.